Okay, guys, we're going to finish up section 1.7 today with 1.7 day 2. So we are going to, that's your warm up, but we're going to be looking at 1.7 day 2, compositions of functions. So in 1.7 day 1, we looked at combinations, which was adding, subtracting, multiplying, and dividing. Today we're looking at compositions, which is when you take one function and you put that entire function in for the other function. So again, a little bit of review from Algebra 2, but we're going to form these compositions, also called composites, and then we're going to look at how to evaluate for certain values and then talk about domain. The domain is a little different here. We're still going to use those critical points or those critical values. So you have there in your notes what a composition is. It could be written both ways. These have started showing up on the ACT in the last several years, so they could use either of this. Notice it's an open circle, so that it's not multiplication. I prefer to write it the second way, so anytime I see the first way, I will rewrite it the second way. That's what makes the most sense to me. So you see there in your example, we're going to find each of the following given these two functions. So we have, again, f of x is a linear function, g of x is a quadratic function. So the first one we're going to find for part A is f of g. That's how we say that, f of g of x. And remember, again, as I mentioned in the last section, when you have an x here, that means your answer will include a variable unless they cancel out. So again, I am going to rewrite this. So f of g of x is how I'm going to rewrite it. And then we're going to start from the inside out. So we're going to take this g of x and we're going to sub in our g of x. So it's going to say f of x squared minus 2x plus 6. So now we are taking this and we're going to sub x squared minus 2x plus 6 into function f. And notice it's in place of the x. So instead of having that x there, we will sub that function in. So if it helps you, you could write 3, instead of putting the x, just put parentheses minus 4, because instead of x, again, this is the x part, okay, we're subbing in x squared minus 2x plus 6. So again, you're subbing an entire function, the entire function g of x, you are subbing in place of x for the f of x. Then all you have to do is simplify. So we're going to distribute that 3 through the parentheses. We still have the minus 4 at the end, so if we simplify that, hopefully my addition and subtraction is correct. So 3x squared minus 6x plus 14. Again, notice there's an x in the answer because you had an x after the f of g there. So the next one we're going to do is we're going to do g of f of x, and we're going to see if we get the same thing. This is called the commutative property as you switch them around. So again, I'm going to rewrite it. So g of f of x. So now we're going to replace the f of x here. So we have g of 3x minus 4. Move this down a little bit. So now we're going to go to function g, and everywhere we see an x, because again, this is in place of x. Everywhere we see an x, we're going to put 3x minus 4. So again, use parentheses, x squared minus 2 times x plus 6, if that helps. And then I'm subbing in 3x minus 4 in its place. Now we have to simplify it. So again, we need to know that 3x minus 4 quantity squared means that you multiply it by itself twice. So 6x squared minus 12x would be minus 24x. If you need to write those out separately, you can. Plus 16, going to distribute the negative. And then we're just going to combine like terms. So try to do those on your own. So you should be getting 6x squared minus 30x plus 30. So then we're going to do g of f of 1. And so you'll notice here that now we put a 1 after this g of f. So that means that my answer is going to be a numerical answer. It's going to be a number. So again, I'm going to rewrite this. So this is g of f of 1. So we kind of did this with combinations in the last section where we were using the graph, and I alluded to this But we're just going to start in the middle, and we're going to figure out what is f of 1. Okay, so if we figure out f of 1, we're going to go up to function f, so it's 3 times 1 minus 4. So that's 3 minus 4, which is negative 1. So what I'm doing here is I am replacing all of f of 1 with negative 1. So we have g of negative 1. So then we're going to go to function g, and we're going to sub in negative 1. So negative 1, make sure you're putting it in parentheses before you square it, especially if you're using your calculator, but even as you write it down. So negative 1 squared is positive 1. Negative 1 times negative 2 is positive 2 plus 6. So we're getting 9. So you could start just, again, right in the middle or in the middle part, f of 1, sub it in, get that result, and then sub that entire thing into g. That's the process. Another way that you could do this, because we had done part B, since you look at part B, it says g of f of x, and notice you had variables in the end. This says g of f of 1, so all you're doing is you're subbing a 1 in for the x. At no point in time are you multiplying by a 1 or an x or any of that. That's not what this notation means at all. Okay, so you could go back up here to part B. So from part B, we had 6x squared minus 30x plus 30, and that was g of f of x. So what I can do is if I want g of f of 1, I could just sub a 1 in there. So 6 times 1 squared minus 30 times 1 plus 30. How about a negative 1? No, wait, it is. What's going on there? Oh, yeah, I was going to say, that's not giving us the same answer. Hopefully you caught my error back here. This is where I really need you guys. Okay, I should have looked at my answers over here. So this obviously is not giving me 9. It should give me the same answer. So here's proof that we can all make errors here. So guys, I don't know about you, but hopefully you did not follow mine. So 3x times 3x is 9x squared. So that's one downfall of me taking the notes without you in person, is again proving that I make silly mistakes. But so this should be 9x squared. So 9 times 1, I was like, that is not working out. So 9 times 1 squared would be 9 times 1 minus 30 plus 30. So it does give me the same answer. Those cancel, and 9 times 1 is 9. So yeah, these definitely should be the same answer. So you could use either way. So good thing I did that to recognize. So hopefully you were wondering how I got a 6 up there. You were screaming at the computer screen, okay? So I apologize for that. So again, when you have a number after it, you're not multiplying by that number, you're subbing that number in. So you have a couple options there. Okay, on the next one, we're going to find each of the following given these two functions. So now we have a quadratic function, so parabola, and we have a square root function. So we're going to get into domain because, again, with square root functions, we know we have issues. We know we have domain restrictions. That's what I mean when I say issues with it. So f of g of x, so we would have, again, I'm going to rewrite it as f of g of x. So this would be f of the square root of 1 minus x. So I'm subbing that g of x in place there. So I'm going to go to f, so I have parentheses there, x squared plus 4, and in those parentheses I have the square root of 1 minus x. So as I simplify that, the square root of 1 minus x, when I multiply it by itself, I just get 1 minus x, and then I add 4. 1 plus 4 is 5, so I get 5 minus x, or negative x plus 5. Either of those are correct. But the key here is, how do we find domain of this composition? So when you're doing compositions, it's a little different. The way that you find the domain of a composition, so a composite function, which is f of g and g of x, f of g of x and g of f of x, is you want to look after you sub in, but before you simplify. Remember when we were doing combinations, we found the critical values. You can find those from the original functions. So we found the critical values from the original, and then we sub them into our results after we added or subtracted or multiplied or divided. However, when you're doing a composition, you have to make sure you do it after you sub in, but before you simplify. So that would be this step right here. This is the step after we subbed in, but we have not yet simplified. So again, we're going to find our critical values back up here from the originals. So when we have a quadratic, guys, there's no domain restriction there, so there's no critical value. But when I have 1 minus x, my critical value here, if I set it equal to 0 and add x, we would get 1. So we have to figure out what's happening on each side of 1. So again, I'm going to make a number line here. And again, after I subbed in, but before I simplified, I'm going to test a point less than 1. So I'm going to test 0. If I sub it in up here, I get the square root of 1 minus 0, which is 0. Okay, and then I would square it, I know, and add 4. But here's the deal. This radical is what's going to cause the issue. So this would be the square root of 1. And again, I would square it and add 4. And that's okay. I would get 1 plus 4, which is 5. So that's okay. All those values work. Let's figure out what happens at 1. If I sub in a 1, I would get the square root of 1 minus 1. Again, really that's the only part we need to worry about, which is the square root of 0. You would square it and add 4, but that works, so that's going to be filled in. If I test a number bigger than 1, let's say I test 2, you would have the square root of 1 minus 2. Again, you would square it, but the square root of 1 minus 2 is the square root of negative 1. So it doesn't matter that I square it. That's an imaginary number, so it is not part of our domain. So our domain here would be x is an element of negative infinity to 1, and 1 would get the bracket because it can equal 1. So the key part here, whenever you're finding domain of a composition, is you look after you sub in, but before you simplify. That's the part you're looking at. Okay, next example. We want to express h of x as a composition of two functions. So you're going to have a couple of these on your homework. So what we're looking for is we're asking what's f of x and what's g of x? That if I did a composition of two functions, I would get h of x. And I'm going to add something to this. We're going to say so that h of x is equal to f of g of x, because it does matter what order I'm going in. Okay, so that h of x would be f of g of x. And again, that's how it might look, but I would probably rewrite that again. So the idea, guys, is we're taking g of x and we're subbing it in to f of x, and we're going to come up with this function. So here's how I think about it. I look at h of x and I try to look for parent functions. I hope when you're looking at that, you see a parent function of the cubed root of x and you see a parent function of x squared. Now, you also see the plus 1, so that's going to have to go somewhere, and there are more than one answer here. But if I look, the fact is that f is on the outside of this when I say f of g of x. So since f is on the outside, think of that as your outer shell. So when I look at this, my outer shell is this cubed root. So I would say that f of x is the cubed root of x, and then g of x is kind of my inner shell. That's the inner part, so I would call g of x squared plus 1. And then you could test it. If I were to do f of x squared plus 1, then again, I would have the cubed root of x, which is x squared plus 1. So that is a way that I could check it. Now, that is not the only answer you could have. Maybe you were thinking of a different one. So maybe you were thinking that f of x could have been the cubed root of x plus 1. And g of x could have just been x squared. And if you would have taken g of x and subbed it in for your x, you would have gotten this answer, and that would have been okay. There's going to be more than one answer that's correct. Let's just try one more of these. You can squeeze this into your notes. What if I give you h of x equals 1 over x plus 3? So again, we're looking for f of x and g of x so that f of g of x is equal to h of x. So again, think of your outer shell, think of your inner shell. So when I look at this, I see an x plus 3 and I see a 1 over x. That's kind of what I see. You could also see a 1 over x plus 3 and an x. There's a couple different ways there. So when I look at the outer shell, Okay, I'm thinking that if I had a 1 over x in my outer shell and I subbed in an x plus 3 in for that x, I could get this function. Again, different ways of looking at it, but you're really looking at the main parent functions with a little bit of a shift. So you could have said 1 over x plus 3, and then you could have said g of x is x. That would have worked as well in this case. You do want to be careful, because sometimes when you're squaring things, you have to make sure you're following order of operations. Okay, the last one here, similar to what we did in day 1, but now we're going to be doing compositions. So they look similar, but they're worked a little different. Remember, compositions is you take an answer for one and you sub it into the other. Notice there are numbers, so we're getting a numerical answer out. This is the same graph you had. So I'm going to rewrite this f of g of -1. So we're starting with g of -1. So go to the graph of g, go to -1, go down and find it. You're looking for the y value. G of -1 is 3. So you're replacing g of -1 with 3, and then a composition again is you're taking that answer and you're going to now sub it in for the other function. So you're going to do f of 3. So now you're over here, you're going to go up to your graph, and then you're going to go over. So your answer is 5. F of 3 is 5. How about let's back up? There's another error on my part. And look back at it. Obviously this is not 3, even though you can't see the line. That's a -3. Let's be smart about where we are. Okay, so this should be f of -3. Glad I looked at that one again. So now we're going to -3 on the x, and we're going up to the graph. So that is a positive one, not what I said before. So I apologize for that. That's what I get for trying to do 3 videos in a row here. Whew. So g of f of 0. So why don't you guys try that one? See if I confused you totally, or if you can get that one, and then I will talk through it. So you may want to pause here. Okay, I'm going to talk through it, but maybe pause and see kind of what's going on here. So as I'm doing this one, I'm going to start with f of 0. So that's my blue graph. So I'm going to go to 0 on the x. I'm going to go up to my blue graph. My line is right there at 2. So f of 0 is equal to 2. So now I'm doing g of 2. So I'll go to positive 2. I'm going to go down to my graph till it hits the graph, and I'm going to go over. And again, this one is negative. So we would get -6. So that's all you're doing on those. So again, if you have questions, email me. Let's set up a time. I'm available before and after school. Also available some during the 8:25 time frame. If we have an optional Google Meet, come see me. Email me questions. I'll try to respond to those questions if I can. Otherwise, we can definitely set up a time to meet if you'd like to do that. But know that I'm here to help, and hope you're doing well, and have a good day. Bye.